Okay, as I was telling you, there are two types of questions we have to answer. One is called the open-ended question. In the open-ended question, we use the two-tail option and utilize the p-value to find out the answer. So an open-ended question is used to find out the difference between the data set of two different data sets. Like if we want to know is there a significant difference in the COD values of Lahore and Islamabad after coagulation. So Lahore is one data set and Islamabad is other data set, and we want to find out the difference. Then we go for the open-ended question, two-tail option. Whereas for close-ended questions, we use one-tail p-value. Like if you want to know if the COD value for Lahore before and after coagulation is significantly increased or decreased. So there is one data set and we are trying to assess the value of our parameter before the treatment and after the treatment. Then we use the one tail method to find out the p-value and use the p-value to find out whether our null hypothesis significantly affect or do not affect the data set. So with that, as I said in the previous slide, that something about the p-value. So if calculated p-value is less than 0.05, which is our alpha value, and this is the value which you select, and depending on the type of work you are working. So most of the engineering work is done with the alpha value of 0.05, whereas biological work is done with the alpha value of, while keeping the alpha value of 0.01, which means 1% chance and 5% chance. Okay, so if calculated p-value is less than 0.05, you can reject the null hypothesis. It means two data set mean are not equal and there is a significant difference between the groups being studied. So if we have applied a treatment on group 1 and group 2 and your p-value is coming less than 0.05, then you cannot say that the two means are same. Then they are not same, they are significantly different data sets. Whereas if the calculated p-value is greater than 0.05, you cannot reject null hypothesis. It means data are equal and there is no significant difference between the groups being studied. So what all this means, how to find all this, I will show you in the coming Excel. So as I asked you in the beginning, I have uploaded my Excel sheet with solution, but you cannot use that Excel sheet because इसमें formula आपको नजर नहीं आता. You have to insert the formula. So I will use my Excel sheet and run it with you guys. You follow the same thing in your Excel, and then the one I have uploaded, compare your answers with that Excel sheet. So before moving, just remember a few terminology that I have put on the Excel. Here H0 is representing the null hypothesis. Null hypothesis is always like we want to say that mean of one group is equal to mean of the second group. But there is also an alternate hypothesis, which means mean of one group is not equal to the mean of other group, as shown here by HA. So to perform t-test, first we have to find out the f-test value, and as I explained in the slides, if your f calculated value is greater than your f critical value, which the system will give you, then use t-test unpaired unequal variance option. Whereas if f calculated value is less than f critical value, then use t-test unpaired equal variance option. So now I'm going to the Excel sheet. So here I have given you some data. So here is my data. which is saying that there are 4 testing sites in Lahore and 4 testing sites in Islamabad, and these are the values of the COD at each site. Like at site C, site 1, COD value in Lahore is 200 milligram per liter, whereas in Islamabad it is 250 milligram per liter. And this is the same way you generate your data through experimental work. So we have 4 sites and 2 places to analyze, and we want to perform the t-test because we have this group of set and this the other group of set. But to perform the t-test, first we have to perform the f-test. And to perform the f-test, so just follow what I am doing. You can use my Excel sheet, save it by another name, and if you perform the same thing, you will be able to get the same results again and again. So we want to find out f-test first. To perform the f-test, go to your data. I have shown you earlier that data analysis, how to insert the data analysis on your Excel sheet. So go to the data analysis, and we have to perform f-test to sample for variance. So let's see, where is the f-test? F-test to sample for variance. That's what I want to perform. So I have selected, I have to select my first data set, and here you can see that I have selected my site name as well, but not the mean which I have already calculated, because the system will generate the mean by itself. And then I have selected the other data set, and since I have used the names of the sites, so I have to use the labels option. And alpha value we have decided 0.05, which is normally used for environmental engineering guys. And then where I want to see the result, I have to select that point. So let's say I want my answer here at this point. So when I will run this, you will see that there is no change in the data, but actually it has run. And just to show you that it's going to give you the same answer, the color of these screens will be changed, but you will be finding the same answer again. So this is the way I am trying to show you how I have calculated the data. So you just press the OK button, and so this is your data, which is generated by the Excel tool. So here we have few things: mean, variance, observations, degree of freedom, f value. This f value is basically f value calculated, which is shown here as f value calculated, and this is your f critical value, one tail. And in the f test, it's mostly one tail which is used. So if you see that our calculated f value is greater than f critical value, so it means, as I have explained you on the slides, that now I have to use unequal variance t-test to find out the answer. And how to perform the unequal variance t-test, I am going to show you in the next tab. So one thing is decided, that I do not have to use equal variance t-test, but I have to use unequal variance t-test with this data set. So now again I will go to the data analysis. The same data is written here, and here now I want to perform t-test. So you have to find out t-test, and it's decided that we have to use unequal variance t-test. So here is to sample assuming unequal variance. So I will select that. And then for the other data set, and then click the labels so that they appear on this table, and my alpha range will remain same. And where I want to find the output range, I want it here. So I have selected this point, and then I have just ordered the system to find the answer for me. So it has generated the answer for me, for us. Now if you see that there are two types of data available here. One is called t-stat and the t-critical, and one is called p-value. We are going to use the p-value now because the whole idea is generated on this p-value calculations, as I have shown you in these slides. So as p calculated value is greater than 0.05, which is our alpha value, then you cannot reject the null hypothesis, because to reject the null hypothesis, your p-value should be less than 0.05. But here we are getting p-value greater than 0.05, so we cannot reject the null hypothesis. So what this means? It means that u1 and u2 are equal, or no statistically significant difference. There is no statistically significant difference for the groups being studied. Similarly, this is if we are going to find out just the effect of increase or decrease of data parameter, and if we want to see if there is a difference between the data set of Lahore and Islamabad, again for the two-tail we are getting a p-value which is greater than 0.05, so you cannot reject the null hypothesis. Means that the means are equal, or statistically there is no significant difference, and groups being studied are the same, have the almost same type of data. So what it is going to give you is going to give you that this treatment, whether you are performing in Lahore or Islamabad, the end results are almost same. Now let's use a data set where we can find out f value which is less than f critical value, so that we can perform equal variance t-test. So here is our data. Again, we have to check whether this thing is this data is made for equal variance testing or not, and for that we have to run our f test first, and if f calculated is less than f critical, then only we can say that we have to run equal variance. If you see here, our f critical value was greater than f critical, so we have run unequal variance test. But here you can see this is the already calculated value here, which I am showing you here, but they will come same when I will show you how to calculate them. If the f calculated value is less, in the previous case it was more than the f critical, do t-test for equal variance. So we know from this that we have to run equal variance test. And how this thing is calculated, by now you should know, but again we can find it out. So go to the data analysis, and in fact again my recording time is about to finish, so I'm